Hey, this is the substitution rule. This is like the antiderivative of the chain rule that we haven't done yet. Remember, we made the list of all the antiderivatives that we have to know and recognize. That's not going away. We're still going to know and recognize those. But now we're going to have some that we're like, wait, I don't know, I don't recognize that. For example, look at this. We do not recognize that as any kind of common derivative. We can't simplify it to make it a common derivative. So this is when we need the substitution rule. Okay, now here's what happens when we start the substitution rule. Then you all think you have to use substitution for everything. We've been integrating for how many class days before now the substitution rule finally was shown to you? A bunch. So don't think that you're going to have to use the substitution rule for every antiderivative now, okay? So today we're just going to do indefinite intervals, and then, because I don't want to go too crazy today, I know your brain could explode or something. But this, just be careful. The quiz that we're going to have next class is not going to have to need any substitution. These problems are substitution. Quiz problems will not be, okay? So we'll probably do the quiz before we check over the homework, just so that's...
Will you remind us again before the quiz, like, don't use substitution? Like, right before we take it.
Yes, I remember. You know my memory's not so good. All right,
I'm glad that's what I do.
Let me show you what substitution looks like as far as notation. You do not have to memorize this because it's just kind of weird. But the substitution, you should recognize this. What does that look like? The chain rule derivative, right? Okay, so what we're going to do, this is the chain rule derivative, and that's what's supposed to be in there. Okay, and then this is what we have to change it to. Okay, be careful how you say that. F of u. Say it too fast. Okay, all right. But we usually use u. We used u when we did the chain rule in the beginning, but this was the memorized chain rule from f of g of x prime, remember? Okay, so we're going to get it. This is hopefully a lot simpler than this. All right, so here are the steps. When using substitution, try to choose u to be some function whose derivative is already there. I'll explain what that means. Same idea. Okay? And then, honestly, most of the time, u is going to be the most inner part of the composite function. Okay? Now, sometimes it works, sometimes it doesn't. Here's what's going to happen, and it's going to drive some of you crazy. Well, I don't know if that's going to work. Well, you try it. If it doesn't work, you try something else. Okay? So, here we go. Let's go back up to here. What's the most innermost of a composite function, probably of this one? Again, 1 plus x squared. So we're going to let u be 1 plus x squared. Okay? Now, du dx. That's the derivative of u with respect to x, because the derivative of u has an x in it. All right, what is the derivative of u with respect to x? 2x, okay? So technically, if we want du to be over here, let's do some weird algebra and tell me what du equals. Say again? 2x dx. Good job, Lizzie. We are taking this dx and we're multiplying it by both sides. Okay? It cancels over here. It shows up over here. Okay, now, check it out. Here's 2x dx. Okay? We are going to swap that out with what it's equal to, which is du. Okay, so here we go. The integral's still there. Dx, 2x dx is du. Okay, what else is there? And what is 1 plus x squared? U. So now we have a simple little antiderivative defined, right? So 2x dx, we said was equal to du, so we swapped 2x dx out for du. Radical was still there. We haven't done anything with it. And we said 1 plus x squared is u, so there it goes. Yes.
So anytime we have to try it, it might not work. You're saying if the EU equals.
You can get du, but sometimes you don't have, like over here where it says, tries to u to be some function whose differential also occurs. If this x wasn't here, we would have a hard time using that for u because we can't, well, I don't know, we can't invent it. We can manipulate with the constants, but if the x wasn't there, we'd have a problem. We'd have to try something else. Good question. All right, so let's take the derivative. What do we probably want to change that to? U to the 1/2. Good job. All right. And then u to the 1/2, we need an antiderivative. What would it be? U to the 3/2 times 2/3. Plus,
Wait, what is this?
we're adding 1 and dividing by that number. There's lots of men in the hallway.
And like,
Oh,
oh my god.
what is it? What is it? Oh, okay. All right, we added 1/2, 1, and we divided by 3/2, which is multiplication by 2/3. Okay, you made the u up, so our answer can't have u in it. So we're going to replace it back with 1 plus x squared.
What happened to the du?
The du always disappears when we take the antiderivative of it. Just as reminding you that that's a derivative there. Good question, though. So there's your antiderivative. Okay? Now, don't forget that you can take the derivative of this and you should get this. Some of you are forgetting that and then you're getting really confused because you don't check yourself. Okay? You take the integral of the function and get something, you should be able to take the derivative and get the integral back. Okay? All right, any questions about this process? We're going to do a few more, don't worry. Good? Okay, try another one. But usually that innermost piece of the composite works. Usually. Okay, what do you want to do with this one? Okay, so we'll let u be x to the 4th plus 2. No. Du dx is 4x to the 3rd. We have the x to the 3rd. What's du? Okay. You're all forgetting how to make derivatives now? That's okay. Pull the 4 around, decrease by 1. This is where it starts getting weird because you really got to think about, am I doing derivative? Am I doing integral? Okay. And you got to be pretty firm in those processes. Okay. We have an x cubed dx, but we don't have a 4. Okay. The 4 is just a constant, so I'm going to pull it over here. That's 1/4 du equaling x cubed dx. I got to find something that I can swap out for x cubed dx. That's what I'm doing here. So as long as it's a constant, I can manipulate. I can throw it to the du side. So this red now is going to become 1/4 du. Okay? The integral is still here. Constant is 1/4 is outside because it's not going to involve our function. And what's left in here? Cosine of u. U is x to the 4th plus 2. So it's a very simple thing from there. Does that make sense? All right, so let's find the antiderivative. It's the only way to get rid of an integral. What's the antiderivative cosine of u? Negative sine of u.
Wait, not
It's just sine of u. Yep. This is where when you check yourself, you will find yourself, you'll say, oh, wait, I have a negative. No, the negative sine of u derivative is cosine. We don't need that negative.
But if it was sine, then it would be negative cosine. Yeah.
Okay, don't forget your C. All right, now what are we going to do for that u You made the U up, so put it back, x to the fourth plus 2 plus 6. That's the, now to pull around and do that derivative, you'd have to use the chain rule, of course. That's why we're doing the substitution, because the chain rule would be required to find the derivative, because it's a composite function. Okay, any questions? All right, let's try another one. You want to try it by yourself? Okay, I'll give you a minute or 2, 3, and then if you're stuck. Sure.
Is that one?
Yep. So 2, so. We don't have that 2, so we're going to do it that. Reset. Multiply by dx. You erased it all. Okay. Du dx is the next step. Equals. Okay, now solve for du. Okay. Now you don't have a 2. Now how'd you get? Okay, this 2 is divided. It should be divided over here. Doesn't end up being multiplied. Okay, here we go. Most everybody's got this, and then this, and then this. Okay? Now, I don't have a 2. 2 is just a constant, so I can divide. So that's 1/2 du equal dx, which I have to swap out. Okay, so I have 1/2 du swapped out for that dx. Okay, all right, the integral's still there, my radical's still there, and my u has been replaced with 2x plus 1, or my 2x plus 1 is going to replace with u. How many of y'all got it to there? Okay, good. All right. Now you should be able to take the antiderivative of that pretty easily. That's an easy level. You got it? You forgot the antiderivative, darling. You. You just stuck the u back in. General's plan. Yep. Yep. Not 1/2, but 3. 2/3. Yeah, about 1/2. Yes. Okay. You're good. Good job. All you need to do is simplify that 2/3 of the 1.
I did it wrong. I just didn't. It's not prepared.
Simplify this and you're good. What did you see? Yeah. Okay, very good. Yep, and you're good. Just simplify those 2 fractions. You should be good.
Where's she getting the soup?
Divide by, okay, you're good. So this is gone now, so because you took the antiderivative of it. Okay, now 1/2 times 2/3 simplifies. And then you put u back. Forget it, Jacqueline? This should be 2/3. That 2.
She just
What? Okay, it's just better. Put a D up there, yes. Alright, 1/2, U to the 1/2. Now ready for integration. 3/2 divided by 3/2, which remember is multiplication by 2/3. So the 2's cancel, we get 1/3, U to the 3/2 plus C. Put your U back in, you're good.
Wait, I can't see.
That's the same thing.
Okay, so,
Yep. Yep.
I don't get what you did with the fractions. Because isn't it
What don't you get?
2? Oh, no, I see it now.
You divide by 3/2,
No, I see it, I see
you
it.
multiply by 2/3. Okay? All right, try that one. No, don't move it to the top till you're, you know what, a negative 1/2, yes. When you said negative, you know what I'm saying, when you move it to the top, you have a power to the negative 1/2. Greater one than that, yes. You make it bring. It's hard. It's work for you.
Oh, but if you like eating.
I doubt it, but you can try it. If you have to, you should be able to get a derivative of it fairly easily. You should not have to use the channel. That should work, yes. All right. Yes, you should be good. Yep. Wait, you don't want to, don't you have an X?
But Summer, can you come see what I did? It's hard to do it, right?
Because you have it.
It's over.
Do that.
Yeah.
And then this is, I skipped the du over dx. Okay, I have x over dx. I don't have an 8, so I got to divide by -8. Don't put it underneath du because you don't want du over -8. That's just weird and awkward. Okay, so x dx is going to get switched up with what? Okay, so -1/8 du at the end. Okay? You always want, you're going to replace dx with some form of du.
Okay.
Because if you're going to switch out that function to u, it's got to be in terms of u, which is du. Because I have to, this is what I can swap out. I have that. I'm swapping out, I'm circling what I'm swapping out. So because I don't have that, I got to get that with my du. Oh, well, yeah, let me give you a little time to get going here. That X over there kind of bothers me. Yes, it looks very off. I mean, where's your integral? Is it still an integral? Your notation is just bad and it's making me kind of nutty. Because if I don't see it, this is what we had, right? Where the x went with the dx and got switched out for the du. Right? Is that what you got? All right, so then that becomes u to the what half? Negative 1 half. The x got switched out with the dx for negative 1/8 du. Because that's what it's equal to. So negative 1/8 du got switched out with x dx. Well, if that's going to stay on the bottom, you got to put a 1 up there, right? I guess I don't know what you're asking me.
Oh, I just thought you were right.
I don't have x over radical 2. I have radical u. I have x dx right here got switched out for this. So if this u is supposed to stay on the bottom, don't I have to put a 1 up there for it to be on the bottom, otherwise it's on the top?
No, but why can't you just do du upright? Like negative du upright.
Because that's just weird enough. When have you ever done an integral that it has la 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 dx over 2? This is weird. We've had integrals out here, because I told you to pull those out. All right, so here we go. Negative 1/8, what's the antiderivative? That's the only way to get rid of an integral. U to the 1 half divided by half, which is multiplied by 2, isn't it? Is it?
No,
Add a 1.
It's not.
You divide by the 1 half, which is the same as multiplication by 2. See. All right, what's negative 1/8 times 2? U to the 1 half. And now we can put our u back in, which is and you can put the radical back or you can leave it like this. Okay? Same thing as that's on top. That's really kind of that would be the same thing. Or usually means you can leave it like that, yes. Okay? You all got to be very methodical about knowing what you're swapping out. Every single time I circle it, it's a visual. What am I swapping out for that? That is gone. In its place is this. What is left? Radical u. Well, if radical u has to stay on the bottom, we got to put something on the top. That's a 1. From there, it should be a piece of cake. Okay, if it's not a piece of cake, then this quiz is not going to go well tomorrow, next class. Okay, if you can't do it from here, then that's what this is about. Okay? Things are getting crazy on me now. Okay, this one is a little bit different. So, is that one? All right, so let's do this together. Because first of all, tangent is not a derivative that's ever going to show up, right? Tangent squared? No. Tangent secant shows up, secant squared shows up, tangent will not show up as a derivative. That's a derivative. Okay, so here's what we're going to do. We're going to substitute is that the thing? Okay, sorry, cat. All right, what does tangent equal besides whatever cotangent? We don't want that here. Is that sine or cosine? Okay. All right. Now, that's not really a composite function, but we can still do, let u be either sine of x, or I'm going to let you decide which one works, because see which one of these will work. One is going to work, the other one's not. You can let u be cosine of x or sine of x. Well, maybe not. Maybe not. That would probably be smart, yes. Which one are you doing, that one? Does that work? Did anybody try u cosine of x? Does it work? So derivative is cosine of x. Du then is cosine of x dx. That's a problem. Cosine of x is down. We cannot pull it up. Okay, so this isn't going to work.
Wouldn't it be negative cosine of x? Yeah, okay.
Oh, no, it would be sine. Derivative of sine is cosine.
Oh, it's regular derivative.
Yeah.
It's a lot.
The negative is the biggest issue with, once you get it all figured out, the negative is still something you have to check. Is that a derivative? Is that a negative? Is that a derivative? Negative?
This is a really bad day
Yeah,
to teach
it's
this
pretty
lesson. This lesson's so intense and we're all just not feeling it.
Okay, so this is this, right? We don't have that negative sign, but that negative sign is just a constant, so we can just do it right. Okay. So we have sine of x dx, right? There it is. I'm swapping that out with negative du. What's left? Over cosine x. Wait, cosine x is u. You would have figured it out. Now, if something is something over, we gotta have something on top to be it over, so that's the 1. Okay, got that? All right, what's the antiderivative of 1 over u? ln, absolute value of u. Don't forget your c. Plug in your u, which was cosine of x. Don't forget your absolute value bars too, because cosine is positive and it's negative, it's positive.
Why is only the ln negative and not the c as well?
Negative c is still constant. See, just because we're adding c does not necessarily mean we're adding a positive number. Go to lunch, ladies. Don't eat too much sugar so you don't have enough sleep. And that'll just about 2 o'clock you'll start in this severe negative energy level.
2 o'clock is the only time I have energy because that's when I'm
Wasn't feeling the flying, Charles? I did it. Ollie went home.
What?
Ollie went home at midnight. Yeah.
I don't think we're allowed to do that.
I didn't know we were either, but seems like smart if you want to do that. That would be a smart thing to do.
I look like